Today we're going to talk about arrays. So first of all, what is considered to be an array? So arrays are used to store values very similar to variables, but the only difference is that they store contiguously. So instead of just declaring, I don't know, like 13 or 14 or 25,000 variables, we can just simply create an array and store all that information there. The way we store this information into the array is by indices. So we're gonna have a zero-based indices, means that we're gonna start at position 0 and we're gonna go all the way to the a.length minus 1. Every time you create a new array, we need to use some kind of mechanism, a keyword in particular called the new, as you can see here. So let us start by describing what exactly we need when we store some variables. As you can know, suppose that we declare here a couple of variables, maybe x1, x2, x3, x4, and x5 with different integers values. This is how we've been storing information for the past weeks. The problem is that when we start to introduce more variables, it's a little bit difficult to handle. What we need to do here is to visualize a box. Suppose that we have a box like the one that you can see right here that it stores 5 values. Now, this representation that you can see here is typically the array representation that in computer science we use in order to visualize an array. Notice that we start at index 0 and we go all the way to the size, which is 5 minus 1. So the first value will be at position 0, the second value will be at position 1. Value from the variable x5 will be stored at position 4. So basically, when you see this kind of values, we always count at value 0. This is very similar to what we have discussed with strings. We play the same pattern here. So every time we see these values, we can accommodate those values accordingly to these positions from this array. The question here is how we're gonna declare this part. And this is the way we're gonna store, we're gonna create an array of integers that hold 5 values. Let us inspect more in detail this formula you can see here. So let's try to visualize what is happening. The very first thing that you see here highlighted is what we call the data type. These data types, they must match, both of them. So if you have an int square bracket in the left hand side, you need to have the int square bracket in the right hand side. So those data types must match. This is the way you tell Java to tell you, hey, can you please store this box in memory that is going to hold 5 values for me. By the way, they're gonna be integers, so make sure you allocate the precise capacity that you need for that data type. The next part is an indicator to tell you, hey, we're dealing arrays. So every time you see those square brackets, that means that we're dealing with arrays. You probably remember this, guys, when you saw something called public static void main and then open those parentheses, string square brackets args. Believe it or not, we were dealing with an array of strings at this point. By the way, the main is a main method that will take an array of string as an argument. And we're going to talk about that in more in detail later on. But I just thought, since this is the very first time you deal with arrays, that you need to make that connection. This part is an identifier. We call it an ID, but basically you can call it whatever you want. I call it A for array. The equals new, it's how you create a new object, a new instance of the array in Java. Nothing new here. Remember how we create a new scanner, or when you create a new file or a print writer? This is the way we basically create a new instance. Okay, a new object in Java. This is the way we define it. We create a new instance. And we're going to talk about more in detail later on when we deal with objects. And the value inside of those square brackets after the equal sign is the capacity. Here is when you specify to Java that you need to have a box, a storage, an array holding 5 values. So this is the general formula to create any type of array with any data type. How are we going to store information? So you can see here in the very first line, how do we declare an array? And the next 5 statements is how we actually assign or store the values in those particular values in the array. Notice that we start at position 0 all the way to 4. Those are the 5 values that we want to store. Array at position 0 contains the value 5. Array at index 1 contains the value 3. Array at index value 2 contains the value of 2. Array at index 3 contains the value 24. Array at index 4 contains the value 7. Now, there's a shortcut. In case you know the values that you want to store, you can use the shortcut as you can see right here. The only thing you have to do is to declare the data type, array int square brackets a equals, and then you open those curly brackets. You separate by comma each value that you find there. For example, here I have 5, 3, 2, 24, 7, and that's the way you're gonna create a array containing those values as a shortcut. You don't have to have those 5 different lines of code there. So the way you access the data from the array, there's probably 2 ways that Java can provide for you. One is by printing the location, and one is by printing the element and the indices. So here in your right-hand side, there's an image that basically describes one of the outputs that we're going to talk about. It's called the hexadecimal address location. So that is the location of the array. I just want to mention that real quick so you can have an idea what is that about. You can use the base 0 to basically access all the information from the array. And one of the helpers, one of the best friends forever, are the loops. So loops can help us to basically navigate through the entire array and access that information. Remember, the array counts very similar to a string, counts with an attribute called the length. The length helps us to extract how many values you have in this particular array, and it can help us to construct those loops. So consider the following array. One natural way to print the values is to use the system out print line and then print the array A in this case. So you might think that you're gonna get all those values printed, but instead we have this. So let us go ahead and explore what this really means. I know it's a lot of weird symbols there in numbers and letters, but this is the way Java recognizes the location in memory where the array is being stored. This is the meaningful part from the computer to the computer. As a human, for us, it's a little bit weird to see this, but let us inspect what this really means. This part is considered to be an array. That is the square bracket representation that Java will indicate that you're dealing with an array. This part is we're dealing with integers. So if we're dealing with an array of doubles, instead of an I will be a D and so on. This is the at sign, which pretty much tells you that the array of integers is located at, and then we're going to provide the hexadecimal address location. Now, hexa means 16, base 16. So basically, in case you want to represent your digits from 0 to 16, you need to use hexadecimal for 1 byte. In other words, from 0 to 9, everything is fine because that's 1 digit. But in order to represent the number 10, you need to use A. 11, B. 12, C. 13, D. 14, E. 15, F. Where is 16? Well, remember, because we start at 0, that is the way we represent the 16 bits. But if we want to store something more humanly, we just need to print those values using the system out print line, like the way we just did here. So this will generate some output like the following. I know what you're thinking. Can we just make this in a simpler way? We're just printing those 5 values using the system out print line, Professor. There's another way to do this. And of course, we can use the loop. Remember that the loops are the best friends forever from the arrays. So let's construct this loop based on this information. And you can see here that we're going to start at position 0. This is a 0-base array. So that's where we declare a variable called int I equals to 0. As long as I is less than 5, because we have 5 values, we're going to go one by one. I++. In the meanwhile, you can see here that there's a lot of repetition with the system out print line. So that will be part of the loop. And instead of just printing A at position 0, 1, 2, 3, and 4, we can just print A at position I. Remember, the I is the control variable that will control the numbers between 0 and 5. Let's trace it. We're going to start in the left-hand side with the loop, and the right-hand side, you can see the tracing of the variable I. We're going to do it step by step so you can recognize both the execution of the for loop and how can we access those values from the array. So we start at I at position 0, and then we're going to compare if the value here 0 is less than 5, which is indeed true. Because it's true, we're going to go to the body of the loop, and we're going to print system out print line array at position I0, so that will give us the value of 5. After the execution of the body of the loop, we're going to go to the update. That means I++. So now we're going to increment I by 1. Now is going to be 1. We're going to go back to the check, and we're going to see if 1 is less than 5, which is indeed true. Therefore, we're going to go to the body of the loop and print system out print line, and then we're going to go array at position 1, which happens to be the value of 3. After that, we go to the update, I++. Now the value of I will be 2. Next, we're going to go back to the comparisons, and we're going to do, is 2 less than 5? That is true. Because it's true, we're going to go to the body, system out print line array at position 2, which is 2. We're going to print the value of 2. We update I++. Now the value is 3. And we're going to go to the check and ask, is 3 less than 5? Which is indeed true. So we welcome to go to the body of the loop, system out print line, array at position 3, which is the value of 24. We're going to update the value of I by 1 more by using I++. Now is 4. We're going to go and check if 4 is less than 5, which is indeed true. So we're welcome to go to the body of the loop, and we're going to do the system out print line array at position 4, which is the value of 7. By using I++, we're going to update the value of I, which is now going to be the value of 5. I want you to pay attention because after the update, we're going to go back to the check. But when we come back here to the check, we're going to see if 5 is less than 5. And in this case, is not true, therefore false. Because it's false, that will terminate the execution of this loop, and we're going to exit. And this is the output that we're going to generate after this execution. How can we simplify this output or this processing? We have .length. It's an attribute that is being provided to the array. So instead of just put there any other value, we can simply just put a.length, and that would automatically do the same output. And the only thing we're doing is navigating from 0 all the way to 5 without including the 5.